You ever wonder how a skyscraper in Frankfurt is guaranteed to be just as safe as, say, a bridge in Lisbon? For a long time, it was kind of messy. Every single country in Europe had its own rule book. So let's get into how they finally solved that problem.
I mean, that's the big question, right? How in the world do you create one reliable standard for safety when you're dealing with an entire continent? You've got totally different climates, different building materials, even different traditions. It's a huge challenge.
Well, the answer, as you might guess, was to create a single, harmonized rulebook that everyone could get behind, understand, and most importantly, trust.
And that solution is what we know as the Eurocodes. Basically, it's a set of 10 standards that create one common language for structural design. This means an engineer can work safely and super efficiently pretty much anywhere in Europe.
So how does it all work? Well, the entire system is built on this core idea called limit state design. And really, it just boils down to checking every single structure against two critical limits.
First up, you've got the ultimate limit state, or ULS. This one's all about raw safety. The big question here is, will the structure actually collapse under a worst-case scenario? Then you have the serviceability limit state, or SLS. This is all about performance. Think of a bookshelf. If it sags way too much with just a few books on it, it hasn't collapsed, but it's not really working, is it? So any design has to pass both of these checks, no exception.
Now, what's really cool is how these standards don't just exist on their own. They actually work together like a perfectly coordinated team. So it all starts with EN 1990. Think of this as the main playbook. It sets all the fundamental rules of the game. Then EN 1991 comes in and defines all the possible loads, or what they call actions. We're talking snow, wind, the weight of people, you name it. And finally, you have all the other codes, which are like specific instruction manuals for different materials. Concrete, steel, timber, the whole lot.
Okay, so that all sounds great in theory, but how does this system actually guarantee safety out there in the real world? Well, it uses this really clever concept called the partial factor method.
It all comes down to this one simple, but really powerful rule. The stresses you put on a structure, the effect, can't be more than the strength the structure has to fight back, its resistance. Pretty simple, right?
But here's the genius part. To build in a safety buffer, engineers first take the effect, all those loads like wind and snow, and they artificially make them bigger on paper. They multiply them by safety factors. So you're basically planning for things to be even worse than they're ever likely to be.
And at the exact same time, they do the opposite for the materials. They take the assumed strength of the steel or concrete, the resistances, and they actually decrease it on paper, again using special factors. So you're planning for a bigger problem while also planning with weaker materials. It's this brilliant double precaution that makes sure the final design is incredibly tough.
But hold on, there is one last, really crucial piece to this whole puzzle. Because the system is unified, but it is not totally uniform.
And that's because each country gets to publish its own national annex. Now, this document is what lets them tweak the main Eurocode rules just enough to account for their own specific local conditions.
I mean, one look at this table and it's obvious why that's so important, right? The amount of snow a roof in Sweden has to handle is just not the same as in Italy. It wouldn't make sense. So the national annex is what allows this amazing framework to be smart and adaptable, blending that common language with essential local knowledge.
So you see, the Eurocodes aren't just some dusty old set of rules. They're a living, dynamic framework that allows an entire continent to build its future safely, efficiently, and most importantly, together.